Welcome everybody. It's time to get rational. Today's lesson is all about rational exponents. Rational exponents are essentially fractional exponents. It's going to be important to remember that the numerator is the power and the denominator is the root. For example, off to the side, I've written 64 to the 2/3 power. In this situation, 2 is the power and 3 is the root. I like to start by always taking the root first and then raising it to the power. So you can see this is 64 to the 1/3 power and then raised to the second power. 64 to the 1/3 is 4, and then 4 to the second power is 16. This is the process that we'll use for each of the examples in example number 1. We're going to ask that you try to do these in your head. Now, some of these exponents could be difficult, but what we're trying to avoid is you using the calculator for each of the problems. I'll walk you through each problem, and then you'll try some on your own. So, first one, 27 to the 4/3 power. This is 27 to the third root raised to the fourth power. The third root of 27 is 3, raised to the fourth power is 81. Whoa! The third root of 64 raised to the fifth power is 1024. The second root of 100 is 10, raised to the third power is 1000. Now this is an interesting situation. My bases are the same, so I can add my exponents. Notice that my denominators are the same, so I can go ahead and add. I get 32 to the 6/5 power. So I do the fifth root of 32 raised to the 6th power, and I get 64. My power rules still apply, so I raise the top and the bottom to the 3/2 power. 64 to the 3/2 is 512, and 9 to the 3/2 is 27. Okay, on the right column you'll notice that all of the exponents are negative. Since negative exponents tell me that the answer goes in the denominator, I can start by putting 1 in the numerator. Each of my answers will be 1 over whatever I get for my power here. So let's check it out. 125 to the 4/3 power, I take the third root, raise it to the fourth power, and I get 625. So it's as simple as what we were doing in the left-hand column, but it should be 1 over 625. Essentially, we're taking the reciprocal. 64 to the negative 4/3 power will be 1 over 256. 625 to the negative 1/4 power is 1 over 5. Alright, since, like I said, I'm essentially taking the reciprocal, I can go ahead and flip my fraction, 49 over 25, and then raise it to the 3/2 power. By flipping my fraction, I have essentially gotten rid of the negative exponent. Alright, the second root of 49 is 7. I raise that to the third power, and I get 343. The second root of 25 is 5. I raise that to the third power, and I get 125. Alright, last, I'm going to do 6 times the negative 4/5 root of 32. I'll end up with 1 over 16. Alright, now it's your turn. Try the on your own problems on the back, and then check your answer. Alright, you should have gotten, going down the left-hand column, 128, 1, 7,776, 2/10, and 8 over 125. Going down the right-hand column, you should have had 1 over 216, 1 over 1,000, 1 over 27, 3, 930, and last, 625 over 16. Now, if you've gotten any of those wrong, go back and check your work, see if you can get the right answer before continuing to solve equations. Alright, in order to solve equations with rational exponents, we're going to do it in basically the same way we did when we looked at just exponents when it was 1 over a number. We're going to raise it by the reciprocal. So for example, in number 2, I will do n to the 3/2. To undo that, I'll raise it to the 2/3 power. And what I do to one side, I must do to the other. So 27 to the 2/3 power. What ends up happening, if you remember your power rules, this becomes n to the 6 over 6, which is n to the first power, so n is all by itself, just like we wanted. And now we do 27 to the 2/3 power. I take the third root, which is 3, and square it, and I get n equals 9. Now before I can raise anything to an exponent, the variable has to be by itself, so I'm going to divide both sides by 2. So g to the 2/3 equals 49. I'll raise both sides to the 3/2. So g is going to equal the second root of 49, which is 7, to the third power, which is 343. Lastly, I need to subtract 5 from both sides. And I get m to the negative 3/2 over 3 equals 9. I then need to multiply both sides by 3. So m to the negative 3/2 equals 27. Now to undo this exponent, I need to multiply by negative 2/3. Raise it to the negative 2/3 power. My final answer then should be m equals 1/9. Remembering that when I raise something to the negative power, that answer goes in the denominator. Now you try. Try that on your own problems and then check your answer. Alright, you should have found that A equals 128. Should have found that D equals 7,776. And lastly, that P is equal to 1 over 125. Now, hopefully you're feeling very rational and this is making sense to you. If not, come to class prepared to ask questions.